you doing?
I'm good.
Okay.
We're back.
Yeah, we're back. We're back on a podcast, which is Language Grows Brains. And we've been talking about how language helps us grow our brains. And we use language concepts, the concepts that are represented by language, our thinking, in other words, in order to refine our thinking. But we also use it in different ways. So, we had this situation where we talked about how, you say one idea, like sit down, and you have different kids have different interpretations of that, and then we talked about how not all of us probably have the same things going on in our brains. We talked about the neuroscience of that with the concept of beaches. Mm-hmm. And then today we kind of want to continue talking about what happens when we refine. And last time, Bonnie drew out a story about the ants. And we talked about all the different opportunities to refine our thinking based upon the drawing, the reading, the writing, the thinking, the viewing, the listening, the calculating, all of those different kinds of things that would take place, all using language, all mediated by language. Right. And that all language has these underlying semantic relationships that actually build the concepts for us to represent those with language. Mm-hmm. Well, the thing is that most of us assume that we all do the same processes the same way in terms of taking in that information and organizing it. And so I told you that there was an opportunity, if you haven't seen me draw out how we learn, that there was an opportunity to do that by going to one of the websites last time and taking a look at it. And if you did, great. Some of you probably already have seen me draw it out or seen Bonnie draw it out.
I actually I could show them that link too. I've done it too.
Yeah, exactly. And so you've had a chance to see it. I think it's also on the NeuroEd Press website. So if you haven't, do that. But it's also a chance for us to talk a little bit about the assumption. We said that language is based upon intention and on beliefs. And one of the beliefs that we have educationally, as well as through some of the other disciplines outside of education, is that we all come with the ability to process the input the same way. I talk to you. You obviously hear the words of my voice.
Right.
You basically turn it into your words.
And I
you
learned
interpret it.
Yeah.
And you've learned it.
Done.
Okay, it's done. It's
Easy
finished.
peasy.
Yeah, exactly. And you move on. In our culture, our dominant culture in the United States, we use that as the basis for teaching things like behavior and academics. And we teach it, all the way up to the university level, where we have
lots of talking.
Yeah, lots and lots of talking heads. Talk. And we assume that when you hear that talk, that not only will everybody in that room have the same pictures or same thoughts in their head, but that we all also have pictures in our heads.
Yeah.
And
when you say processing, say processing it, what do we mean by that?
Good question, because that's used differently too a little bit. In looking at language as a set of structures, processing is input-output. So it basically means I say it, and you pick it up, and you use it.
Yeah.
Okay, so I said, the shabooey-kabing, and she picks up shabooey-kabing, and she can now say it.
Shabooey-kabing.
Oh, she's got it.
Yay, I learned it.
She can say it, okay? If I tell her to do something with it, this is shabooey-kabing. Do shabooey-kabing.
Shabooey-kabing.
There we go. She almost got it. We'll try it again. Shabooey-kabing.
Shabooey-kabing.
There we go. Now we got it. So everybody knows what that means. Well, no, because it's never been used.
But you taught me, because I gave it back to you.
Exactly. And that's kind of the processing that we assume from a developmental perspective. That's the processing of language. It goes in, it comes back out. Okay? And you'll hear kids try to imitate the parents at a very young age, 18 months to about 36 months.
And then we talked right before we left last time about patterns and like what that meant.
That's a pattern.
Yeah.
Shabooey-kabing is a pattern.
Right.
Because you could imitate it.
Right.
Say anything that you can imitate. I go to a website. I copy down what that website says. I put it in my term paper and I turn it in to the teacher. I just copied somebody else's language, which means that I just gave them a bunch of patterns.
Right.
And it's not addressing the question that I was supposed to write about. It's giving somebody else's language to the professor or the instructor as if they were my own. So we call that plagiarism. And if you change a word or two, I've had students say to me, well, I didn't plagiarize, I changed a word or two. Okay? If you have to imitate or copy and give it back, then it's a set of patterns. It's
Right.
not language.
And patterns stay midbrain.
Right.
They don't. It's almost like a signal in your brain that doesn't attach to anything. It's there.
Right.
You can practice it, I guess, and
Yes.
keep it there.
Yes.
But I think of it as if somebody was trying to teach me how to speak Spanish. I don't speak Spanish, but they can teach me a word,
Right.
and I can repeat it back to them. I might even learn how to write it. Does that mean I use it as a Spanish speaker?
Fluently.
No.
No.
It's because it's still a pattern to me.
Right.
I think about high school calculus. I took high school calculus. I even passed a few of the tests. Do I know anything about calculus right now? I'm sorry to admit I don't. Those of you who do, thank you. And I should probably learn more about it. Those are patterns to me. They didn't
Yeah.
stay with me.
No.
And we do this. We can do this as adults, right? We can learn something in the short
yeah.
term, pass a test, do the thing, but it doesn't stay with us.
No, 6 weeks from now, we don't have it. Those of you that have the young kids, maybe over the weekend they don't have it. So on Friday, you check them off in that little checklist, and
Because
you
they
go,
passed a little
they
test.
know their numbers, they know their letters, they know their multiplication, whatever it is, and you go, this is great. You take a weekend, you go do your family thing, and you come back on Monday, and the kids look at you like, you never taught us that.
Right? I don't remember that.
Yeah.
I don't remember that.
Yeah.
We hear that a lot. And the question, the thing, people are like, well, why? Why aren't I told it to them? Why
Yeah.
is it? Why aren't they getting
Right.
it? Why aren't they learning it? Well, that goes back to how we process our patterns. How
Exactly.
we process patterns. How our brain and our receptors are dealing with the information coming from the outside.
That's right.
Basically.
And so when we say processing from a psych standpoint, from a speech path standpoint, education standpoint, processing is internally taking the sensory input and having a motor output. And that's typically what we look at. Well, then what do you do with the rest? What do you do with those concepts, those ideas we've been talking about? What do you do with language? Well, that's part of the mind. See, and that's how it's dealt with. It's dealt with as a mind, as if the mind exists separate from the brain. Well, we got a little problem there because there's no physical place for the mind in
Other
the
than
body.
brain.
Okay, so either the mind and the brain are the same, okay, or the mind is created from the brain, or through the brain, or by the brain. Okay, but somehow we've started the first day talking about connections. Those connections still exist. There has to be some way in which the brain is involved. So you can't, as you said, the sensory input comes in, it starts working through the sets of pathways that connect the peripheral system to the central system. As we're moving up through those pathways in the acoustic and the visual systems, okay, we get to a point where they have to start connecting and interconnecting with what is already there.
Correct.
Okay,
Which
and
means
that's
they
where you
have to
get the
be
circuits,
meaningful.
which means that's when
Yeah.
you get the images or the concepts.
Yeah.
But see, if that only belongs to the mind, then why do we know all the stuff about the brain? But we do, so why do we ignore it? I don't know why we ignore it. Because to be perfectly honest, okay, we should probably be embracing it and saying, okay, is that parallel to what we know about language? Absolutely. Okay, is it what we know about the structures? No, it's what we know about the functions of language, how language is designed to help us communicate, to refine our thinking, to refine others' ideas as well as our ideas, and to help us with our own behavior, our own social development.
And while those are being refined, we see them being refined on the outside as
Right.
as we change, our behavior changes, and our learning grows. In the brain, those processes are basically happening.
Right.
They're being refined, pruned, becoming more efficient,
Inhibited.
growing new
Yeah.
networks that are expanding and increasing. Right, more brain cells than there are stars in the sky. Right, there's so much potential there.
That's
if
right.
if we can process what's going on. But over and over at school and life and trainings for adults, I mean, honestly, 5, 15, or 50, we're all learners, okay? We just are like, why didn't they? I told them. We say that with our own kids. I told you.
Yeah, how many
And
times do I
why-
have to tell you?
I've told you. Why
Yeah.
didn't they learn it? Why
Exactly.
is there all this summer learning loss? Why does this keep happening?
Yeah, why do we have to
know?
start every year and
With
to
a review.
reteach and,
Yeah,
review
yeah.
for 3 months, and then we do a couple of months, and then it's time for testing again.
Yep.
So it's really it doesn't make it very fun for the educator or the parents. Okay, because the kids can't wait to get out of that classroom and run down the street and get home where they can actually use their own thinking and use their own brains and get out of that. Well, there's something else that we haven't talked about because we talked about the fact that we have these different ideas as a result in processing. So we have the 2-level processing, input, output. But then the concepts in language, that's level 3 and 4, where the circuits and the networks come together. And it's at that point that we get the refinement of those concepts, like for apple and table and some of the examples that we gave. But there's also the fact that we don't all have the same genome or the same genetics. We don't all have the same processing system in those higher levels. In other words, our brains are unique not only from experience on the outside, but neurobiologically on the inside.
Correct.
And so what that means is that not all of us are going to take the information that we hear and actually hear it. And just so that I give a context a little bit to the people that are listening and watching us, is that when I went into the field back in, the late 1960s, and early 1970s, one of the tests that we would give kids for language at kindergarten level would ask the kids to do a 3-part command. I'm going to give you 3 parts. I want you to do what I tell you to do. And we'd cover our mouths and we would say, I want you to take out a piece of paper and I want you to color. Take out the piece of paper. I want you to color the snowman, and I want you to use your red crayon. Okay? And if the kids could do it, they were spot on for language and cognition and that type of thing. It usually had to do with manipulatives or something, but it was
3 instructions.
It was 3 instructions.
Yes.
Yeah, in a row.
And you were covering up the movement of your mouth.
Exactly.
So like
they couldn't see the mouth.
Right.
They could hear it, but they couldn't see it. Okay? And what I noticed is that none of the kids that I was seeing that had any problems with any kind of language or communication, reading or writing, that none of them were able to do that. And so, by the 1980s, I started to actually devise little tests to give to some of my students, especially the ones that didn't have a diagnostic label, that were in regular education, many of them in private schools, so they had high expectations, and why it was that parents were helping those kids when they came home. They'd do 5 hours of school and they'd do another 5 hours at home because the parents were actually interpreting everything that had gone on in school. So the parents then had to know how to do the geometry. The parents had to know how to do the algebra. The parents had to know how to do the book reports, okay? So we had those who could, and then we had the parents that had their own lives and didn't have time for whatever reason to do that. And so all of a sudden it became, in the 1990s, I'm looking at this going, we've got about 60 to 90% of our kids who can't do that 3-part command. And we've got parents who are continuing to help the kids get through. But what's happening with that is that then the next generation, are kids that also can't do those 3-part command. So what appeared to be something that was being changed by maybe ear infections, environmental kinds of changes, the more TV, computers, that kind of thing, what that was doing was that we were actually seeing the brains change.
So phenotype became genotype.
Absolutely.
So the environment was, and there's so many studies on how environment actually changes biology.
That's right.
And so the environments these kids are growing up in, we're actually changing the hardwiring of the
Absolutely.
brain. And I think this might be a quick thing to say then. Are we talking about those learning styles people have?
No. Learning styles are preferences, and they were pretty much debunked, to be just perfectly honest about it. In the 1980, 81, 82, there were a couple of major reports that were produced in the Senate by parents who went and testified about their kids with learning disabilities having learning styles that didn't match with what was being said, and how education really didn't define who they were. And so most of that learning style stuff has been put to the side.
So we're
Those
not
are straight
talking-
preferences. So I might prefer to think in the shower.
Yeah.
Okay. But fortunately for everybody watching today, I'm not having to do that. Okay.
Right.
I can think right here as I'm sitting here.
Right, exactly.
Okay, talking.
But I think that's important to mention because a lot of when we start talking about how the brain is processing information, sometimes there's a misunderstanding that it's somehow a choice. and it's just something we like as
Right.
opposed to how our brains work. And-
Or we ourselves as adults have gone through learning style kinds of preference
yeah.
sheets.
Yeah.
We've done that for the job, for the interview,
Yeah.
for the teaching position, and then we take it to our kids, and we do the same kind of thing with the kids.
Yeah.
And we try to impose upon them what it is that we're thinking and believing, and not necessarily how the kids are actually processing the information. So 60, 90%, and I'd have people kind of question, well, 60, 90% of the kids can't really do a 3-part auditory instruction. And I'd say,
purely auditory, no visual cues.
Yeah. And I'd say, well, just go back into your classroom. I don't care what age you're teaching. Go back in your classroom, put your hand up here and give a 3-part command. And people would come back and they go, oh my gosh, nobody seems to be able to do that.
Yeah.
Well, then, by the time that we had the studies in the early 2000s after the 1990s, okay, what we started to see was that number wasn't 60 and 90%. That number was 90% or above. And then in Bonnie's classroom, we actually looked at the kids' language, and we did that, for 10 years?
Well, we did, but one year you actually took language samples of each
very
kid.
Detailed.
Very
language
detailed.
samples.
And it was a fun class that year. Pretty diverse, language diverse class.
Oh, definitely, because it was a
lots-
Title I school.
And I think there was 6 different languages or more represented in the classroom that year, like different language, like Russian, Spanish, Tagalog. I mean, there was a lot. Chinese, Vietnamese, Spanish is a lot in that. Very
we said
truly
Russian,
multicultural, as I'd like to say, right?
Yeah.
And she took language samples of that cohort, very in-depth ones.
Yeah.
And it was like 25, 26 kids and only one.
We had one kid, and in fact,
That
in
could do
the
it-
years
that
of
could
the
do
taking
that,
the language sample out of 140 kids, something like that, you had that one kid that was in that class that one year.
That could do that,
That,
completely auditory, no visuals.
Right.
Following instructions,
Yeah. So what that means then is that, there's some changes here, but what the neuroscientists have discovered is, you want to give them the
that
information?
study?
Yeah.
Yeah, some cognitive neuroscientists wanted to think about the mind's eye, and they surveyed 1,500 adults. This wasn't that long ago. In fact, there was a is it Pixar? The head of Pixar. They did an interview with him because he was part of the study, and of 1,500 adults, only 5% reported not having any images in their mind's eye. So 95% of those adults said, well, of course, different images in my mind's eye. I think in this way and that way. And it was they found it so unusual that people didn't, and this is what we do in our culture, we have to label that difference, that they gave us a name for the people who don't have pictures in their mind's eye.
And that kind of matched with what the people were saying that did the neuroscience study with the beach, was the same kind of thing, is that these people don't have an imagination. Well, what we're really talking about here is that it's not about imagination.
No, because the head of Pixar reported not having any pictures in his. I mean, this guy has imagination,
obviously,
right? And so they called it aphantasia.
It's called aphantasia.
If you don't have pictures, so they say it's a disability,
or you don't have and you don't have an imagination, that type of thing. And I've had a good friend of mine who's a physicist say to me, he said, "Well, you can't do science because you can't see anything in your head," and I go, oh, wait a minute. I love my science.
Yeah.
I've always loved my science. I'm really good at science.
Yeah.
So
there's no doubt anymore that we have a chunk of our population, 95% of adults at least, that think in a language in their head or process in a language of pictures and visuals of some kind. It's in the literature. This is not in doubt anymore. And the funny thing is Ellyn talked about this about 40 years ago. But it's nice that the science has caught up and the studies have caught up, right?
Well,
anyway,
we're getting there.
Yeah.
And I think it's because, again, when you know language, then you understand some of this processing bit.
Yeah.
So if you look at your screen, you're going to see that there's a slide up there, and it says, we have this 95% that basically can take what they see on the outside. So we're seeing out here. We're not talking about the mind's eye. We're now talking about physically. I hold up the book, okay, and I can see, okay, and then I see what's on that page. So those are visual patterns, okay, and then I take those visual patterns and I connect them. I overlap them with other visual patterns, ones I already know, and I put them together and they form visual concepts. So in that picture, you have this little gal that is looking at something, and on the left-hand side, what you'll see is the edges, like when we did, or Bonnie did the drawing with the black on white with just the edges. You see the edges of what might appear to be a cat. Well, that's really honestly what the eye sees, okay? And the brain sees that too, unless you have language. So what the brain has to do is the brain has to take and overlap all of those edges to create basically a shape, which will then become a concept at some point. So in the first two levels of processing, in that sensory input with perceptual patterns, what you actually are taking in with your eyes, okay, is basically a 2D black and white type of piece of information. And you're starting to get textures and you're starting to get colors, but you haven't put it into something that's 3D that moves around in space, okay? So then on the right-hand side, you see what happens if we overlap the patterns. We have multiple cats, and as we overlap those multiple cats, they actually form an image. And that image could be of your own cat. It could be an image of a cat that you saw in a book. It could be an image of a cat, the neighbor's cat, okay? But what you then see is based on your language. So without any language, you can't see anything up there at that level of conceptualization. And that's really important to understand. Because when a kid says, I don't know, when they said, I don't understand, when they say, I can't read, when they say, I can't do that math, I don't know what that means. What they're saying is, I don't have enough overlap patterns to form concepts, and I don't have the language, because if I had the language, I'd be able to explain it to you. That's 95%.
Yep.
But if we go to the next slide here. Sorry. There we go. There are a few of us, like Bonnie and myself, and my friend Carol that was sitting at the conference for the beach piece. There's a few of us, the 5%, that can do what we think language is supposed to do. Because remember, we're this culture that goes around talking, right? And the teacher talks to the kids. The teacher tells the kids what to do. The teacher gives the instructions. The teacher gives the directions. The doctor, you go see the doctor tells you what you need to do. You know, that you go to your attorney, the attorney tells you what they're going to do. Okay, we have this culture that basically says, if you listen to me and I have told you, then you have learned the language for it. And therefore you have the knowledge and you walk away with the concepts that you need about that, whatever it is. Okay, well, some of us are able to take in the sound. Okay, I hear the sound of my voice. When Bonnie talks, I hear the sound of her voice. Okay. In the sound of my voice while I'm talking, I'm also hearing the sound of my voice thinking about what it is that we're going to talk about next and how long we've already talked in this group and how far we have to go, you know, and make sure that we don't go too long and keep you here too long or, you know, that type of thing. So I'm having all these kind of layers of sound in my head. They're all in my voice. It all belongs to me. It's all my language. I have no visual graphics whatsoever with any of that. Okay, none. And I know that's hard for 95% of you to understand, but you have to understand it's my culture that you are teaching in your classrooms.
Yeah.
It's to me 5% that you're providing instruction for.
Super comfortable for me. Just tell me what you want.
Yeah, I can sit in a lecture hall of 500 people, 1,000 people, and ace the class.
Yeah.
I don't need to see the instructor. I don't need to be up close to the professor. I don't need to even see the slides. You just tell me what you're doing, and I'll take it in my notes, my language in my notes.
Yeah.
Okay?
Now, I will not write your words. I'll put it in my words.
Exactly.
I don't need you to repeat yourself. I don't need it twice.
No, and you tell me what the sounds are that go with the letters, and then you tell me what the word is. If that word is in my language system, I got it.
Yep.
You don't need, we don't, please, don't keep giving me the sounds.
I got it. I got it
the first time and the second time and the third time.
And what's really important is to remember that because, and we can go this more, but that English is an auditory language.
Absolutely.
By its very nature. Therefore, our culture assumes we all learn in this manner that you're seeing on the board. It's auditory. That we take the visual and the sound at the same moment. It connects neurobiologically in the brain at the lateral lemniscus. I looked that up.
Yes.
And it connects instantly in the brain, and that process forms auditory concepts. It's a different process when your system is processing visual concepts, a different there's so many ways that things can be processed. But this is a very, I don't know, it's going away, this system, this learning system. It's not that it's weaker per se, but
No.
but it's just,
Well, our brains are changing.
Yeah.
And our brains are changing for lots of reasons.
Mhm.
Okay. We, are basically protecting ourselves from things like having middle ear infections that would change the way we'd hear sound. We don't let kids die anymore from middle ear infections. We give them
or other
antibiotics.
childhood illnesses like measles, that would give you a brain infection or something like that.
Yeah, encephalitis or
now
something.
we live through those things, or we don't get them, and we pass that on to our kids. So their brains are wired a certain way.
And then what's really interesting about the human brain is that it's the only brain out there among animals that actually changes with the input.
Yeah.
Okay, and what changes are all those neurosemantic circuits. There's something that happened. Some people believe it was a mutation or something that took place in the human brain, thousands of years ago. I mean, hundreds of thousands, in which it actually opened up the opportunity to change itself. Okay, whereas other brains don't do that. You can teach a chimpanzee language structures, okay, and they can even do a sign or two to the next generation. But then it's lost. They don't keep it because they don't need it. It's not functional. It doesn't have the same changes in the way in which it's used. It can't get refined. And it can't go up into that neocortex and be used that way. In our human brain, what you put in changes it.
Right, and there's actually some good research on this, and a great book called The Brain That Changes Itself.
Yeah, exactly.
Great book.
Awesome book.
About how literally in real time you can rewire your brain.
Well, it gives cases.
It gives cases of this happening.
Different people,
what we can't change, though, is how we process, because we process how we process, right?
Yeah. By the time we're about 2, our systems neurologically are pretty well set up for the way it's going to take. And when we say process, that's that 3rd and 4th level.
Right.
It's going to take the sensory and perceptual patterns, and now they're going to become concepts. And it's the concepts that are probably by age 2 are pretty well starting to form, okay?
Right. Yeah.
And the brain is starting to prune in that way, and therefore it's going to continue to process that way. Now, if you have an auditory system, because the auditory system is made up of acoustic sound and visual things that you've seen, because it requires both synergistically to be used together, then if you have damage to the brain, it will go back into the stronger physical system, which is the visual system.
Yeah, remember that in many ways, neurobiologically, the auditory system is less real estate. It's smaller. Like the visual centers of the brain are quite large.
Oh, very large.
The motor centers of the brain, quite large. These are the strength of the brain in many ways.
Yeah.
So yes, the auditory,
and they're bilateral.
Yeah,
whereas the auditory system tends to have a dominant side, then the visuals it tends to use both sides.
So in some ways, if you think about it, there's damage. We're going to default to the strength that's still there, which often is the visual motor, which means So
that would be good.
Yeah.
We used to be in a sarcastic way. I would hear people say, "Do I have to draw you a picture?" Yeah, please.
Yeah, please do it, because it actually would help.
Let's do it. Yeah, it actually would help me learn.
I think we're hitting. I'm keeping an eye, and I think we need to wrap up for today.
Okay.
Yeah, I think we've done a lot, talked a lot about this, and I think people could think about this between now and next time. Like, how do I think?
Yeah. Because I bet you that there's some of you out there going, well, am I auditory? Am I visual? How do I do this? Just keep in mind the processing part. And it's a really good question to ask yourself. And we'll pick up next time. So thanks for coming. And we will see you next time.
Yeah.
Bye.
Bye.